There are times in statistics when you will want to construct a confidence interval for a population proportion. A proportion is a part or a number in relation to the whole. It is given as a percentage. For example, 78% of all dogs bark when the doorbell rings. And this 78 can be written in decimal form as 0.78 or as a fraction, 78 over 100, which can be reduced to 39 over 50. And 78%, 0.78, and 39 over 50 are all equal to each other. As an example, let's say that in a random sample, 122 people were asked if they liked their boss, and 88 of them said yes. We're going to use this example to go through several different formulas and symbols that are important to understand and that are used in proportions before we get to the confidence interval formula itself. The proportion of a sample is written as P with this little symbol above it, and this is called P hat. And this P hat is a point estimate for the population proportion, which is written as P. And P hat is equal to X divided by N, where X is the number of successes or the number of sample units that possess the characteristic of interest. So in our example, X equals 88, the number of people who like their boss. And N is the size of the sample. So in this example, N equals 122. P hat then is equal to 88 divided by 122, which is 0.72 or 72%. Another important symbol is Q with this little symbol above it, and this is called Q hat. Q hat is equal to 1 minus P hat, or N minus X, over N. And in our example, 1 minus P hat equals 1 minus 0.72, which equals 0.28, or 28%. As with other confidence intervals, in a confidence interval for a population proportion, we get a point estimate and then add and subtract a margin of error to construct the interval. The margin of error, big E, is equal to Z alpha over 2 times the square root of the quantity P hat times Q hat divided by N. Z alpha over 2 is a Z-score based on the confidence level we're using, which is usually 90%, 95%, or 99%. And I have the Z values listed for those percentages. So the formula for the confidence interval for a population proportion is P hat minus Z alpha over 2 times the square root of the quantity P hat times Q hat divided by N less than P hat plus Z alpha over 2 times the square root of the quantity P hat times Q hat divided by N. And confidence intervals for proportions must meet the following criteria. N times P hat must be greater than or equal to 5, and N times Q hat must also be greater than or equal to 5. Also, the sample must be a random sample, and the 4 conditions for a binomial experiment must be met. Real quick, a fixed number of trials, only 2 outcomes, must be independent, and the same probability for each trial. Now for an example. Let's say that in a recent survey of 4,225 people, 2,873 of them said they watched pro football every Thursday night during the season. Find a 90%, 95%, and 99% confidence interval for the true population proportion of people who watch pro football Thursday night during the season. First, the sample is random, and it does meet the 4 conditions for the binomial experiment. Next, we need to calculate P hat and Q hat. P hat is equal to X divided by N. X is the number of successes, which is 2,873, and N is the size of the sample, which is 4,225. So 2,873 divided by 4,225 equals 0.68, or 68%. Q hat equals 1 minus P hat, so 1 minus 0.68 equals 0.32. Next, we need to make sure that N times P hat is greater than 5. And 4,225 times 0.68 equals 2,873. So we're good there. And N times Q hat, 4,225 times 0.32 equals 1,352. So we're good there. Now we can construct our intervals, starting with the 90% interval. And the Z alpha over 2 value for 90% is 1.645. So plugging into our formula, we have 0.68 minus 1.645 times the square root of 0.68 times 0.32 divided by 4,225 less than P less than 0.68 plus 1.645 times the square root of 0.68 times 0.32 divided by 4,225. And calculating out, we get 0.668 or 66.8%. Less than P, less than 0.692, or 69.2%. And the margin of error equals 0.0118, or 1.18%. For the 95% interval, we have a Z alpha over 2 value of 1.96. and plugging and calculating, we get 0.666, or 66.6% less than P, less than 0.694, or 69.4%. And the margin of error is 0.014, or 1.4%. And for the 99% interval, we have a Z alpha over 2 value of 2.575. And plugging and calculating, we get 0.662, or 66.2% less than P, less than 0.698, or 69.8%. And the margin of error is 0.018, or 1.8%. As expected, if we compare the intervals, as the confidence level increases, for 90 to 99%, the margin of error also increases. Alright my friends, that be the basics on finding a confidence interval for a population proportion. Hopefully this video helped you out. I do have more videos right there for you. Till next time, I am out of here.